So one of the big trends that we're seeing at the moment is this movement away from very specialized agents to sort of more generalized agents. And this has been going on for a while. The challenge is it's basically been limited to proprietary models up until recently. So in this video, I want to look at MiroThinker, which is an open model with an MIT license that is built for this sort of AI research agent use. And it's not actually the first version of this model that they made. This is actually a new set of models that has just come out a couple of days ago that focuses on the whole idea of getting a model to team up with a certain set of tools or MCPs and then being able to have it do many steps to actually go through. So that could be multiple searches, using the information it gets back with other tools, then using that to do more searches, to doing a whole bunch of different things. And the key idea here is that if you've got a model that can use lots of different tool calls, and this model is claiming that it can go out to 400 tool calls, then the goal is that you should be able to have something that can do a whole bunch of different tasks from not just things like research, but things that could generate a whole bunch of high quality outputs, whether that could be a slide deck, a report, hooked up to audio to make a podcast like Notebook LM, etc. All of these things require high quality thinking about what information the system actually has already and what tools does it have that it can use to use this information to perhaps find more information and then work on that output. So this idea is not new per se, right? We've even seen it with open models. So for example, one of the models that I really like a lot that's actually been very good at this are the Kimi K2 models, or specifically the Kimi K2 thinking model. The challenge there is that you're talking about a trillion parameter model, right? That's a huge model. It's not something that you can easily run locally. It's not something that you can easily run cheaply. The thing that sets MiroThinker 1.5 apart from that is that we've got two models here, both of them trained off the Quen mixture of experts base models. So the big one is the MiroThinker 235B. So that's got 22 billion parameters active. And then the smaller one is the 30B with 3 billion parameters active. Now, both of these models have been improved from the original Quen 3 base models to be able to do these max tool calls, etc. So the models have a max context of 256,000 tokens, and they're supposed to be able to go out to 400 tool calls. Now, I've yet to see any model go out to 400 tool calls in an elegant way where it can actually not just end up going into loops and repeating itself, etc. But this model certainly can be used for doing lots of tool calls. So this whole element reinforces what we're seeing more and more of moving away from just a big model that has lots of information into it to moving towards models that can do lots of tool calls, use lots of tools for both research, but also for generating outputs, and do that in a fully agentic way. So if we have just a very quick look at their benchmarks here, we can see that their models are comparable against models that are much bigger than this for these particular kinds of benchmarks that require a very high level of tool use, etc. And we can see even in many of them where they're not state of the art, for example, the humanities last exam here, we can see that the bigger model is not that far behind Gemini 3 Pro in here, and even closer with GPT-5's high-level model and the GLM 4.7 models. And sure enough, they've got some benchmarks for browsers, etc., where they are actually the state-of-the-art model. For me, that's actually not that important. I think nowadays any company can really hill climb on a particular benchmark to get something that's state of the art. Really, what I'm more interested in is overall, how are they comparing to other models that are out there? And you can see, sure enough, the MiroThinker models, both the big one and even the 30B one, actually compare quite well to things like DeepSeek V3.2, the Minimax models, and things like the GLM and the Kimi K2 thinking models. So if we look at how these actually work, we can see the tool interfaces that they've got here for doing things like creating sandboxes to run code, file management, being able to do information search retrieval, being able to search the web, etc., being able to pull things in. And then obviously to be able to do this with a very long number of steps, they need to be able to handle the context management as well. So we can see here dealing with the different context retention, working out when to truncate results out, etc. And you can see you're going to get something like this, where you start off with something where, okay, you've got a user question, you've got the assistant doing thinking, tool calls, tool results, perhaps more thinking, etc. as it goes through. And this recency-based context retention here will work out what to actually cut out of the context. So this is a similar thing to the way a lot of the memory systems out there are working, and things like compaction on code tools, etc. And this whole idea of trying to bake this into a system definitely seems to be the way going forward. We're already seeing Anthropic do this with the Claude models and Claude Code. We're seeing OpenAI do it. We're even starting to see some examples of Google doing it for some of their products. And the big challenge is we want to be able to do this locally, right? We want to have models that we can run locally that can do a whole bunch of these different things. And this is where this 30B mixture of experts model, which is based on one of the Qwen 3 models, really seems to shine for me. So currently there isn't a paper out for the 1.5 version. But if we look at the paper for the 1.0 version, we saw that they basically take these pre-trained models, they do SFT on them, they do some alignment training with DPO. They also do some RLVR, or reinforcement learning with verifiable rewards, via using GRPO. And the idea here is that you can get these models to be able to actually make the right decision with the right tool at the right time. And that's the whole goal here. So let's jump into a notebook and have a look at how it actually works. Okay, so to run this model at full resolution, you're going to need a pretty big GPU. I'm using an A100 with 80 gig of RAM here. You probably can get away with something a bit smaller than that, but you're going to still find that this model definitely uses a lot of GPU RAM. The other thing that's different in this notebook is, rather than you do it through the Transformers library, I'm actually running it as a VLLM server. This is so that we can actually use it as an OpenAI configured model. Not that we're using OpenAI or anything like that. What I mean is that we're actually using the OpenAI API, and VLLM has that built in by default. So we can actually just spin this up, and then we can just make API calls to it, and we'll be able to use the OpenAI package, etc., to call it. It will then handle the function calling in that way. Now, actually loading this model up takes quite a bit of time. The weights are quite big. It's got to download, etc. So you will find that you're sitting there for quite a few minutes while it's actually just downloading the weights. All right, then they've got a bunch of tools that you can set up for this. So you can just use something like DuckDuckGo Search for the searching. That's going to be free. You need to fetch a web page tool. For this, you can just use requests and Beautiful Soup. Still, these old-fashioned things actually work very well. If you wanted to, you can actually sort of improve the tools. When you're getting something back, you actually clean it up before you give it to the model, etc. But these basic ones work quite fine. We've got some calculate tools. We've got stuff for running Python code, stuff for getting dates, etc. And then we can basically just define all of those tools to pass them in. We've got some code in here for testing the tools to see, do they work? Sure enough, we can see that the web search stuff is coming back with just 2 results in this case. Our calculator's working, our date time's working. Now we can set up the sort of toll cooling loop in a sort of MCP way. So basically it's got a bunch of stuff in here for doing that. We've also got our prompts that we're going to pass in. We've got some functions for actually passing the tool calls as they come back. And then we can set up an agent loop, etc. in here. Now, the agentic stuff is doing it all from scratch. We're not using any sort of framework like LangChain or something like that. I think in theory, you probably could use that. I do think we're going to see more and more, though, that people optimize a harness specifically to match a model, or specifically to match a sort of family of models. We're seeing some things like that already from Qwen Agent. But in this one, there's really nothing special in there. We just got simple calls, simple prompts for doing this, how to deal with tool calls, how to deal with things coming back. All right, then we can just basically run the agent and kick things off. And you can see, sure enough, we're going to ask it some math stuff first. And we can see that we've got thinking tokens of what it actually needs to do. So it's working out what tools. We can then see that, okay, it's going to use the calculate tool, what's going to pass in there, and we get results back. Finally, in this case, it then uses some other tools before doing a sort of web search and coming back. And this is one of the challenges that I find with these kind of systems is you often it will get to the right answer, but then how many steps did it take? And were all the steps actually related to getting that final answer? So this is where you often want to build some of your own evals for testing this kind of thing out. So next up, we've got a web research task. You can also see here we're passing in the maximum number of iterations of how many steps can it go. And so here you can get it to do multiple calls on this. We can see here it's found the Hugging Face page. It's found a bunch of different things. It had things to itself about that. It then goes to the web page fetch tool to actually go and get each of those pages. And we can see in this particular case, it actually reached the max iterations, right? Because we were asking it to fetch multiple pages. Each of those is a different tool call. So in this case, we actually never got to the final answer out. Now, you can get to much more sort of interesting things of where you've got these multiple step research things. And this is where often one of the sort of deep research things, what they'll do is have one prompt that will write a plan like this of, I need to do this, I need to do that, I need to do this, and then pass it into the agent with lots of tools to actually go through this. And we can see that's what's going on here. So we can see the user wants to understand, it goes through it. It's decided that it's going to go for a big search here. It's going to get the results back from that. We've got some warnings in there. And it's good to see things like this, where it is aware that some of the things coming back are irrelevant. So it should discard those. That's been one of the problems in the past, is that agents would actually just go and do a search, and then they would just take everything at sort of face value and feel that they had to use everything, even though the large chunks of it were irrelevant. This is something where getting better quality models allows us to get better quality results. And in this case, I would say that the model actually hasn't done a great job, right? It seems to have been influenced by a lot of different things. And then either because we haven't given enough steps, it's running out of steps of where it hasn't been able to follow through on this. Now, if we want to get better results, often what we're going to need to do is actually just give it a lot more max iterations for the tools, etc. So you can see here in this one, I'm asking it, what is the current date and time, and what day of the week is it in Singapore? And in this case, the actual server is not running in Singapore. It's running in the cloud somewhere. So it's got to work out, okay, what can it do? So it's got a current date time tool. And a lot of the times these things would just go, well, that's the date, I'll return that. But this thing is working out that, okay, this is not actually the time in Singapore, right? That this is the UTC time, and it will actually go through and run different things. Now, I'm not sure if this is because of the model or because of the prompt, where sometimes it will start to go into Chinese results and stuff like that. In this case, it actually goes through, does get a number of results back. And I can see that as I'm recording this, this is actually correct. It's found the right date, the right time, that kind of thing. But the fact that it's taken 9 iterations or 9 steps of tool calling and stuff like that to get that result is not ideal. And this sort of shows where things are and what a challenging problem this still is, especially when you're trying to do it with smaller models. But overall, this does seem to finally get to the right answers for lots of things. And my guess is that if you're running it locally and you perhaps don't need everything real time, this is possibly going to be really useful for doing lots of different tasks. Now, one of the big things that I do wonder is if we were to swap this out, because basically this model is just the equivalent of the Qwen 330B A3B, this model here. We were to swap this out for an MLX 4-bit version or something like that, how much will we actually lose of the reasoning qualities? So for a long time, people thought, including myself, that once you're going down to 4-bit, you're losing too much precision on the model, and will it affect it? But over the past couple of years, with all the quantizations coming out, this has been shown to not necessarily lose as much as we perhaps thought you would at the start. So if someone were to actually make MLX 8-bit or 4-bit versions of these, they could actually work very well with this harness and something like Llama CPP or LLM Studio, etc. Now, if you want to try the model out, they've also got an online demo where you can actually come and play with it yourself. You don't have as much access to the actual tools and stuff like that, but you can see what the model's actually doing. And my guess is that this is actually the bigger version of the model, not the version that I used in Colab, which was the smaller version of the model. And you can see that pretty quickly just by the longer thinking that we're getting in there. You can see in this case, it's gone and done a bunch of searches, it's found a bunch of websites, it's pulling it back, etc. So if you are looking for something that can do long, both thinking and long chains of tool calling, but be a small model, this is definitely worth checking out and just seeing how it works out for your particular use case. Anyway, as always, let me know what you think in the comments. I'm very interested to see, are people actually looking to run these kinds of models locally? And what are the use cases that you're trying to do locally with this kind of model? Anyway, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.